Welcome. In this video, I'll be talking about how to solve a system of linear equations using determinants. So please subscribe. So solving a system of linear equations involving two variables can be efficiently tackled using determinants, specifically to Cramer's rule. So today we'll be talking about Cramer's rule. This method is useful when the system consists of linear equations with two unknowns. We're gonna take a look at a step-step guide to solve such a system using determinants. So let's say we're gonna consider a 2 by 2. So our system is going to look something like this: a1x plus b1y equals c1, and a2x plus b2y c2, where a1, b1, c1, a2, and b2 and c2 are constants. So Cramer's rule provides a straightforward way to find a solution for x and y using determinants. The rule applies when the determinant of the coefficient matrix is non-zero. So our system looks something like this. And the coefficients we're going to get in from here. So the coefficient matrix is going to look something like this: a1, a2, b1, and b2. So to calculate the determinant of the coefficient matrix, we're going to do as follows. So the determinant is going to be a1 times b2 minus a2 times b1. We're also going to calculate the determinants for x and y for each variable. So that's going to be done a little similarly. So first we're going to replace columns we're going to replace the columns for A. We're going with the first column of A with the constants C1 and C2, so the one on the other side. So so AX is gonna look something like this. It's gonna look C1, C2, and then B1, B2, and then of course we're going to calculate the determinant for X, for the X variable. So it's gonna be C1 times B2 minus C2 times B1. Similarly, we can do the determinant for Y, something like this. So of course AY is going to look something like, so A1, A2 stays the same, and then the B column, because the Y where the Y is going to be located, so we're going to replace it with C1 and C2, and of course the determinant is going to be equal to A1 times C2 minus A2 times C1. And then to solve for X and Y, we're going to do, so each determinant is going to be the determinant value of the X is going to be divided by the determinant of the coefficient, and similarly the determinant of the Y is going to be divided by the determinant of the coefficient. So we can look at one example right now. So to illustrate the application of Cramer's rule, let's consider a specific example of a system of linear equation, a 2 by 2. So our system is gonna look something like 2x plus 3y equal to 5, and then 4x minus y equal to 11. So we can get our coefficient matrix to look something like this: 2, 4, 3, -1, and then our ax is going to look something like 5, 11, 3, -1, and our ay is going to look something like 2, 4, 5, 11. So we calculate the determinant of the of the coefficient matrix A, and it turns out that if we do the calculation, it's going to be equal to -14. So we find that D is equal to -14, because we multiply 2 times -1 minus 4 times 3. We get -14. D is not equal to 0, so the system has a unique solution. Then of course we have the ax and the ay, and we can calculate the determinant for each variable. So dx is equal to, according to what we did, is 5 times -1, 11 times 3, it's going to be -38, and dy similarly, we're going to multiply 2 times 11 and then minus 4 times 5, and that's going to give us 2. The final step is to solve for x and y, which is what we wanted. So it's going to be dx over d, and dx is going to be equal to -38 over -14, and that simplifies to positive 19 over 7. And then y is going to be equal to dy and then over d, and that's equal to 2 over -14. That simplifies to -1 over 7. So our solution to our systems of equation is going to be 19 over 7, comma, -1 over 7. So these will be our solutions. Thank you for watching. Please subscribe.